All right, we are on again. We are on again. Okay, now, let me explain something to you about friction and gravity. Okay, now, if I take these two books, right? Is this book heavy?
Yes.
Yeah, it's pretty heavy. Okay, now, and so I go like this. It's hard to, I mean, I can do it, but I got to push a little bit, can't I? Yeah. Yeah? Okay. How about if I take this?
Doesn't affect it.
Not much, huh? I can even hear some of the friction, but it's not bad, huh?
Yeah. But how does it
Okay, now, how about if I take this tissue? You ready?
Nothing.
Not much, huh? Right? Right? Not much friction, right? How about this?
Okay, yeah.
Not a little bit more, but not much, right? 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 Same shininess, right, as this. Why is this, though? So, why is that? Why is there more friction there? Yeah.
Because there's more gravity acting on an object with more mass. So, like, the gravitational force of an object depends on its mass. If an object has more mass, there's more gravity, and if there's more gravity, it's more like more.
Guys, be quiet, please.
Onto the surface, so it causes more friction.
Okay, this is big, guys. You're right. Now, this is big. And we've done some of this before, okay? You're all right with that?
Yeah.
Okay. Here I have a surface, okay? That's completely straight. It looks curved, but it's not. You got to get glasses. It's perfectly drawn straight line, okay? All right, now. All right, I know it's terrible, so let me draw a little bit better one, okay? You ready? So, all right, now, so I'm gonna put a small object on here. Okay. Now there are two forces. The force, first of all, let's see what the force is. Force equals mass times acceleration. Do you understand that? True or false? Newton's second law. We've done it. You are Jedis. True or false? F equals ma. Mass times acceleration. That's going to be force. Yes or no? Easy? Right? I'm not suggesting that you have to write a paper on it and deliver it in front of the United States Congress. But, okay, you're all right with that? Maybe a little bit intuitively, yes or no? Can I have some response? Are you zombies or are you following me? Yes or no? Yes, could be. Yes or no? A force times acceleration, mass. All right, now, listen carefully. Now, listen. Quiet, please. Now, if I'm going to say that this, when something accelerates like that, g, and it's going to be 10 meters per second squared. That means that it's going to be 10 meters per second every second. So if I drop something, it's going to increase its velocity 10 meters per second every second. That's what that means, right? Yes or no? Yes or no?
Yes.
So you're saying that 10 meters per second divided by seconds. Yes or no? Yes or no? Okay. Multiply by the reciprocal, right? Okay. So 10 meters per second times 1 over seconds equals 10 meters per second squared. Yes or no? That's where that squared comes from. Correct? You're just following simple math rules, right?
Yeah.
Yes or no?
Yeah.
Okay. So I drop an object and it's going to accelerate 10 meters per second. I drop an object. After 1 second, it's moving how fast? 10 meters per second. After 2 seconds, it's moving how fast?
20 meters.
20 meters per second. After 10 seconds, it's moving how fast?
100 meters per second.
Correct. Okay, you get it?
Yes.
Okay, good. Now, what did you say? After 20 seconds?
No, he said after 10 seconds.
Oh, after 10 seconds, 100 meters per second. I forgot what I was saying. Okay, good. Now, there's a relationship. Are you guys accelerating right now?
No.
Yes, you are.
What?
Can you feel?
The
Can you feel, no. Can you feel your weight?
Yes.
You're sitting in a chair, you can feel that weight, right? Yes? You don't think about it, but you can feel that weight, right? Now, what you're doing is this. This is what you're doing. This gets a little complicated, guys, so you got to follow me. Is everybody with me?
Yes.
You with me?
Yes.
Okay. So let's talk about me. So we don't talk about you. We'll talk about me.
Yes.
Okay? My mass is 100 kilograms.
Ooh, I was right.
That's my mass. 100 kilograms. Okay? I'm a big guy. Okay. So we know that force equals ma. So the vertical force sub W, right, meaning my weight, is going to be Fw equals mg. G equals 10 meters per second squared, right? So what's my force? My force equals, my Fw equals 100 kilograms times 10 meters per second squared. So my force, my weight equals what? 1,000, right?
Yeah.
So 1,000 meters, 1,000, careful guys, you gotta follow me. This is really hard. You've got to stay with me every second, okay? Is 1,000, 100 times 10 is 1,000, kilograms times meters per second squared is kilograms meters per second squared, right? Now, this is key. Kilogram meters per second squared is going to be Newton. All right? That's where the Newton comes from. Okay, now, this is tough. This is hard. This is hard.
Oh, I'm sleepy.
All right? You okay with that? Can I erase some stuff here now?
Yeah.
All right, I'm going to quit after this. Trust me, because this is getting a little bit crazy.
Yeah.
But let me hang in there for like 5 minutes. Give me 5 minutes.
Yes.
Okay? Now. All right, now. So I'm going to erase this stuff. All right, now. Now. So my weight equals 1,000 newtons. So that's my weight. Right? 1,000 newtons, right? You okay with that? Now, am I accelerating?
Yes.
No, I'm not.
You said.
Right. My acceleration due to gravity is still 10 meters per second.
Yeah.
But am I balanced? Are my forces balanced? And what's my force balanced with?
Gravity.
No, I push against the board with a force. No, I push against the board. I push straight this way. What's pushing equal and opposite back? The board, right? If I push 100 newtons, what's the board going to push back? 100 newtons. So it's the same. Correct now. So this is Fn. That's what's pushing back. Yes or no? That's pushing back. Do you feel something pushing back? You feel the weight going down, but you're being pushed this way, right? Don't you feel the seat, the stool pushing you back up? Don't you feel the stool? Don't you feel it? Yeah? The stool is pushing back equal to your weight. So I'm standing on the floor, and I'm pushing down on the floor, how many newtons? 1,000 newtons, right? How much is the floor pushing back? 1,000 newtons, right? That's Fn. Yes or no? Right, now, this is key. We're almost done. If I accelerate that way, am I weightless?
Yeah.
Why am I weightless? Yeah, I don't have this. You stand on a scale, and the scale reads, you know what a bathroom scale is?
Yeah.
I stand on a scale, and the scale reads 1,000 newtons, right? 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 Okay. Right? Is that pushing back, the weight that's pushing back, or the weight that's pushing down?
it's pushing down.
No.
Why?
That's the weight that's pushing up. That's the normal force. The normal force is the force pushing in the opposite direction. Yeah. So your weight pushes down. The normal. I'm almost there. The normal force pushes up. Right? Yes. Right. So if I fall this way, aren't I weightless? But I still have my weight, right? That's why I'm accelerating, right? But what am I missing? If you take that normal force away, what happens? I tie that scale to my shoes. I tie the scale to my shoes, and I fall. Right? What does the scale say? 0, right? Right? Doesn't say anything, right? So I'm accelerating that way. Don't I have my weight? So what does the scale read? The scale must read what? The normal. You see that?
Yeah.
It's a thought experiment. Do you understand that?
Yes.
If I accelerate this way down, don't I have my weight? Because I'm accelerating, right?
Yes.
Okay. But what does the scale read? 0. The scale reads 0. I'm falling this way. I'm falling down.
The scale, right, doesn't read your weight, it reads the weight that it's pushing back.
That's right. Is it pushing back?
No.
No, it's not. So it's going to read what? It's going to read 0. Right? Because it's not pushing back, is it? So when you stand on a scale, what is that reading? Is that reading your weight? Or is it reading the pushback force? It's the pushback force. Yeah, you get it? You've got to. If you don't do this, you will never remember this. Are you ready? You've got to explain that to your parents tonight.
Yes.
If you explain that to your parents and then come in and tell me, we're going to talk to see what happened. You get that?
Yeah.
This is what you got to explain. You got to explain that how to get your weight. It's your mass times 10. Yes? That's your weight. Yes? Because everything is the acceleration due to gravity times the mass. That's your weight. You're pushing on the floor. If you have a bathroom scale, take your bathroom scale out to show them. What's pushing back? Your parents are going to say that it's your weight pushing down. It's not. It's your weight indirectly, right? Because I can read my weight by my normal, right? Right? Yes or no?
Yes.
Yes, go ahead.
Isn't the normal is the same force that you're exerting, right?
If you're not moving. Yes, it is. In other words, if you're in your bathroom and your bathroom hopefully is staying there, hopefully. That would be really weird. Okay. Then tomorrow, what's today? Then on Thursday, we'll talk about what happens in an elevator. Oh my God. Oh my God. I know, really. Like, oh my God. Now, and then what we're going to talk about, we're going to talk about different kinds of friction. Rolling friction. What are the different kinds of friction? Sliding friction.
Fluid friction.
Fluid friction.
Sliding friction.
Sliding. What kind of friction is air friction?
Fluid friction.
That's fluid. How did you know that?
Because
Yeah, because what's a fluid?
it's like oil.
No. Don't be specific. Don't give me examples. Give me a definition of a fluid.
Liquid.
No. Air's not a liquid. Yeah.
Water. There's other materials that float easily.
Nope. What is a fluid?
Air water.
Nope. What? Chatty.
Oh, fluid friction because flows easily.
Oh! What'd you just say? Well, you gave the answer.
Easily.
Yeah. Anything that flows, well done. Listen to me. Listen to me. Listen to me. The definition, did somebody else say it?
Yeah.
My apologies. Okay. But wait a second, I didn't teach you that, but you figured it out. Interesting, hey? Don't you want to apologize? That's on the tip of your tongue. Okay. Now, anything that flows is a fluid. So that's why air flows, right? Right? Air flows. You can feel the vent. Can you feel the air flowing? That's air conditioning, right? That's a fan. Air will flow, right? Water will flow. Anything that flows is a fluid. So a fluid is a liquid or a gas, right? Okay. So the next class, we're going to talk about different kinds of friction and momentum. We're going to do, this is on the agenda. We're going to talk about what happens to your weight in an elevator when the elevator goes up and down, what happens, what kind of frictions there are, and maybe we'll demonstrate them, and then momentum. That's a little weird. What is momentum and why should you put on your seatbelt? Very easy. You know what? You know what? The reason you put it on your seatbelt, I can show you with 5th grade mathematics.
Whoa.
Oh.
Genius. Oh, Einstein.
Hey, I'm finished, but we've got a lot of reading to do. You guys look a little bit glazed eyes over. You're still working, but I'm not ending class. I'm finishing the films because otherwise, you guys are gonna be blah. Okay?
Yeah, yeah.